welcome to the group exhibit Hydrogen Fuel Cells and Batteries at the Hanover Fair 2017. We are here at the Technical Forum and my name is Muriel Burkas. We are at the last presentation of today and I would also like to give a warm welcome to the people watching this presentation online through our live streaming. Please have a seat, join us for the last presentation, have a coffee, have some drinks. It's all for free on the house. The last presentation will be regarding a practical example, hydrogen, connective link between heating, electricity and the transport sector. Please welcome with me on stage the CTO of H-TEC Systems, Heinrich Gärtner.
Thank you. Yeah, good afternoon, ladies and gentlemen. It's a pleasure for me to be here and give you a short introduction to our joint hydrogen project, which we figured out in the last months and which we are going through here. Short introduction of our company. The GP Joule company is the mother company of the H-TEC Systems. H-TEC System provides the technology, GP Joule provides the concepts and is working on the concepts where we can add and insert and work with our renewable energies in all the ways we can imagine. Company founded in 2009, roughly 180 employees today and several divisions about project development, planning, financing, construction, over the development and research and development for storage technologies and concepts for intelligent usage of energy in the future. Development of energy and cross-sector concepts for local communities, which is an important sector for us. And with our sub-brand Connect, the mobility and energy solutions for companies indeed. The H-TEC Systems company you can see here on the booth next to the system here. Sorry. Okay. Can you hear me? It's okay. The H-TEC system deals with the technology behind that concept. H-TEC develops PEM electrolysis systems, focusing on stacks, PEM electrolysis stacks, and since Monday we had our start of sales for our products. On the one hand, the stack in a smaller size and the complete electrolysis system in a container size with a peak power at the moment of 350 kilowatts. Oh, okay. Okay, so technical issue solved. A few words about power to gas, which is our point here. As we, as a GP Joule, developed projects for production of fluctuating energy out of solar and wind, several other technologies, we found out that this is only one part of the problem to produce the energy. The other part is to put it in storage systems, to provide it on demand and to the customer in the amount and at the place they need it. For that reason, we had to think about storage technologies and we had to develop something like the missing link between production and consumption. Power to gas is the technique we are dealing with, and H-TEC Systems is developing the technology for that. We have at the moment the situation of a rising portion of fluctuating energies in the energy market, especially in the electricity market, and we try to couple that sector with all the other energy sectors and try to bring the energy over the way of power to gas in the sector of demands like chemical industry, transportation, to the national gas grid, or even over storage and reconversion again in the electricity market. The idea behind our hydrogen joint project was that we have an interlinking of the sectors energy production, electricity production out of the wind and on the other hand, bringing the electricity into the mobility market. Here we have the idea of the production of 5 electrolysis systems, 200 kW each, directly placed at stations where we already have local heating, district heating grids available. We add on that system a transportation, that means one tank truck that is collecting the hydrogen out of all the electrolysis systems. And then the processing sector, we are up now to build there 2 filling stations and provide there the hydrogen that is produced by the windmills in the end to public transport buses that are driving on their routes there. Here you can see the overview where that should happen. It's in a very northern part of Germany, Schleswig-Holstein, where we have here shown in that overview where the bus routes are, where the filling stations are located, and where the five local places are where the electrolysis systems are integrated. What we had to do was a feasibility study to show that it is possible to integrate the hydrogen produced out of this wind power in the renewable energy transportation sector. And for that reason, we had several points to reach, like the emission-free mobility, like show that the model for the smart integration for decentralized production is possible. One of the goals is to increase the acceptance in the area there. It's an area which has to deal with a big amount of installed wind power engines at the moment already, with a more or less weak grid, not really a weak grid, but a grid that's not capable of all the electricity that can be provided there over the wind power sector all over the time. And so we have times for shutdown just out of a lack of the grid. So the economic feasibility that touches on the one hand the revenue that can be generated out of that project. We have on the one hand revenues out of the sales for hydrogen to the public transportation. On the other hand, in the model at the moment is included that the project purchases the buses and then leases the buses to the public transportation sector, so that the risk of running these hydrogen fuel cell buses is not with the communities there, but with the project. So what I mentioned already, the sale of the waste heat is something we have included in the project, so that we can add a third sector where we can provide energy to. As you already know, for sure, we have roughly 25% waste heat out of our electrolysis systems, 75% efficiency, 25% heat, and this waste heat is provided to the local heating grids. On the cost sector, for sure, purchase of electricity, water, and on the other hand, operating for the personnel that works there, site lease, etc., and all the fixed costs. What you can see here on this chart is the production cost for the hydrogen. At the moment, we have free of charge electricity. What happens there more and more often, a lot of hours we have there shutdowns on the grid or reduction of the power due to the lack of grid. There are several scenarios you can see here. The dotted line shows in the end what is the comparable price if you produce here at the moment the hydrogen out of conversion from natural gas. That's what we have to meet in the end. here in more detailed way how the development of the costs will be over the next 8 years. We can see we have a nice curve going down the road over the next years. It depends, as always, on the amount of hydrogen we produce, the efficiency we can use in that case, and a lot of other facts that you can see in that tableau down there. So the conclusion out of our study is the project is accepted, it is feasible, and we even can work in an economical, sensible way already now. The decarbonization technologies can be integrated in a good manner here, and we can reach all our legally and technically and economically goals. It is possible and it's achievable to bring all that together, and we can show it already now. What is necessary for sure is for the future that we have the possibility to avoid additional taxes, that we have to avoid other problems buying the energy, and that's it's indeed a problem that we have to deal with the politicians here, and what we are working for all the time. For the detailed information, you have the chance to download that study we have provided in German and English, and you have the contact details of our Timo Bovi, who is in charge for that, and he can give you all the detailed information on that study. Okay, thank you for your attention.
Thank you very much. Thank you very much, Heinrich Gärtner. Are there any questions from the audience right now? No? I was wondering, the project, what is your vision? You want to implement this in other regions as well of Germany, or just in special regions near the coast, or what do you have in mind?
We try to show that it is possible to connect the sectors, to interlink them together, and make it in a regional and in an easy way. It's important to have some pilot projects there, some studies where you can show that from the technical point of view, the legal point of view, and from the acceptance point of view, it is possible. People often have the situation, they see an installation, a windmill, whatever, have no contact. Here you can really feel what happens. The wind blows and you can take the hydrogen, you can produce regionally, and you can use the bus. You have an advantage out of it, and that's an important point here, to generate value in the area.
Did you hear about the big hit project from ITM? It's going in the same direction, but on the island near to Scotland. Mm-hmm. You've heard about that?
Not too much details.
Okay. I think it would be interesting to exchange, because I think it's going in the same direction, mm-hmm. regarding trying to have a whole community living from renewable energies. Mm-hmm. So thank you very much for your contribution today. It's the last presentation of the day. If you want to have more insights, the H-TEC Systems booth is C58. GP Joule would be a little bit more behind, not part of the group exhibit itself. Thank you very much for your time today, Heinrich Gärtner. And we will continue the technical forum at the group exhibit hydrogen, fuel cells and batteries tomorrow morning at 10 a.m. I'm looking forward to have you here again tomorrow morning. Thank you very much.